Hi guys, how we doing? Welcome back to another video. So in these sorts of video series tutorials, I'm going through how I use SkyCAD for free to create my electrical drawings or electrical schematics. So the plan here is I have this PLC test rig at home that I use. I've got a Siemens 1200 there. I've got an Arduino Opta PLC. I've got a little mini PC here, plus a little HMI, which is just a touchscreen display I've got, and then I've got it running an Electron.js app, little push button station, power supply, some circuit breakers. So this is a rig that I use at home to basically teach myself any sort of concept that I want to learn. So one of the things that I want to do is I want to get a stepper motor and have it control two stepper motors and synchronously and sync them up and move them back and forth. But mechanically that's quite a big challenge to do. But yeah, that's one of the things that I want to learn to do with this rig that I've got at home, right? So I don't have drawings for this rig, and I wanted to just get something up quickly, but then I figured, you know what, it'd be a good idea to do some tutorials on SkyCAD, so that's what I'm doing here. This is part 2. There is an part 1 of this video in which I started off with a blank project, and I set up this first page here, which is table of contents, and then I've started my power distribution page, and then I've just got 14 other sheets. So this is a pretty, it's a very small, if you think about like in terms of a machine. Let's close this. In terms of a machine, where am I? This is a tiny machine, right? Like, if you was doing a machine, a proper machine, some drawings have 150, 250 pages. So hopefully ours will be limited to 14 pages, which should be a nice little tutorial for you guys. So I've done a table of contents, and that gets updated automatically. I've also done my parts list, and that gets updated automatically. So let's now start with our schematic. So I've got a link here to my power supply, which I've got off of Amazon. So let's just find that. Yep, continue shopping. Cool. So this is my power supply. Let's see if we can actually find it on the internet. Comb. Deserts. I was just wondering if it's like a brand with a data sheet and stuff. Seems, maybe. It's a comb. Let's search comb. I'm just seeing if like this is an official part. Obviously, if you were doing a proper machine, you'd be using like a Siemens power supply or something. I can't find a website for this thing, but yeah. All right, that's fine. So yeah, that is my power supply anyway. So let's now copy. Should we go with Amazon or this? We'll go with this. So what we'll do is we'll go over to our symbols library over here, and then we're looking, I don't know what we're looking for actually. I forget. It's been a while since I've done this. Power supplies. And then we have a power supply here which takes in an AC input and gives out a DC output, as you can see there, right? So it takes in line, neutral, and then gives out positive, negative 24 volts. Or this doesn't specify, it's just a standard switch mode power supply, AC to DC. So if we double click it now, that we can open up our properties for that, let's say. So manufacturer on the left here, I'm going to put, I think comb, is it? Seems to be just comb, yeah. So manufacturer is comb, and then the part number is, I don't know if it says on the Amazon listing. Yeah, it doesn't, it's had it on here. Product ID, I think, that should do. But I don't know, that could actually be this desert cart thing. Power supply. Just trying to see if I can get a proper desert cart. Yeah, it might just be. It's a shame that we can't find 20 comb 24 volt power supply. Obviously, I'm just using some off-brand thing here, so it very well may not have a part number. But for now, let's just put this. For whatever reason, if somebody else was to come across this drawing later on in life, they can maybe find the exact same power supply I'm using. So we can put a web link to it. I don't normally do this on my drawings, but I guess there's no harm in doing it. So if I put, oh, is it gonna let me? Okay, it's not letting me for some reason, which is fine. Okay, yeah. So just right click paste. So put a web link. Let's put a description, which we're just gonna copy all of that. 6.25 amps. And then we could put a description here. I'll just show you how to do it. Again, I don't normally do this. Sorry, not description, an image. So if I do downloads, save there, and then image, downloads, where's the image? File, save as. It says it's cancelled. Let's do this. Screenshot it, paint, save, downloads, PSU, save, close that, back here, PSU, there. And then so there are certain places in which it's quite helpful to have an image, like, so I'll just show you here now. When I click OK here, now if I click on this circuit breaker and then click back on here, it shows me the bottom left here, the image of the device. And I found that to be pretty helpful. Like when I've been flicking through my drawings sometimes, and I've got like different push buttons. I've got S1, S2, S3, S4, S5. When I'm clicking through, I can just see, okay, blue, green. So sometimes I add the images, but I did that at the beginning. I kind of dropped it afterwards. So I won't do it anymore other than just on this one for this tutorial. Just an example of how to do that, yeah? So I think that's all we need to put. Okay, input voltage, let's put 230. And output voltage 24, and power, don't know what the power is, it is 150 watts, and current is 6.25 amps. So where this becomes pretty useful is on your parts list. Now you can see there I've got a nice big chunky it automatically updated there. And then what you can do, which this gets really powerful, is you can actually start to click here and then you can show hidden columns. And this is cool. You can now come here and then so input voltage, output voltage, power, current. I can now start to like show certain columns. So if I do show column there, it will now show that column. And then now if I come back to let me close all these other tabs. So come here, close all except the selected one, come back to my parts list tab. If I hit refresh now, okay, so it's not that I have to refresh, but if I insert the list block again now onto here, I then get that same. Now instead of just having it end at quantity, I now have a current column as well, which is pretty cool. So for now I won't bother, but I think it is pretty neat that you can add different columns there and show different things. For me, I think this is more than good enough. The drawing reference number or drawing reference name, the class name, the description, manufacturer, part number, and quantity. That's good enough for me. So if we go back to power distribution, let's go to our parts list and then just hide this column again. Yeah. Cool. So parts list. I quite like that it's wrapped the text and dropped it onto different lines. I quite like that, but then it is going to end up being a massive. You have to split this across multiple pages, but yeah, that's fine. So back to power distribution. So we've got our power supply. We're obviously going to put that top left, as you do in the EU and UK. And then, do I want to draw the line in neutral? I don't feel like I need to, or I should do, because it's not really part of my rig. I don't really care about the line in neutral. I just plug in the 3-pin IEC connector. So I don't know what to do here, if I should do it. So power connection. So anyways, on the left here you got different groupings, right? So I've just got the power supply one from there, and if I now come back to connections, I can then do power connection, 0 volts, control connection. So one of these I made up myself. I made a new connection, so you wouldn't have one of these. So I think you get power connection and control connection. And I think I copied this power connection by doing right click, copy. I pasted it and then I made it black and called it 0 volts. So you might not have that. So I got ground, cable connection, shield, IO connection. So I don't know what to do here. If I click the power connection live, don't know if it's worth me doing this. So that would be my live, and then neutral. I kind of like there. So that says just cable connection, blue. I don't know if I want to do that. And then ground. Again, I don't know if I want to do this. I'm kind of just thinking whilst talking here. Oh, bit awkward. Yeah, that seems a bit unnecessary to me. Ultimately, I don't care really what's upstream from there. So, anyways, pretty cool that it put in the 150 watts and 6.25 amps and 24 volts 230 there. That's pretty nice. So if we go back to my circuit breaker, I think I don't actually have a circuit breaker after my I don't actually have a circuit breaker. Yeah, I don't. So because I'm just disconnecting power from here all the time, just plugging in and out the IC connector, I then go straight into, or do I? Okay. Just pause 1 second. I'm just gonna have to just spin around and actually check this because I can't tell from the cabling. Does that then just go straight into these two banks of terminals, or do I actually go to a circuit breaker first? If I do, that circuit breaker shouldn't be there positioned there. It should be positioned before the terminals, which would make sense. It makes sense to have a circuit breaker that you turn on and off. So I'm not sure why I haven't done that. I think mostly because I know I control power from this left side. So, one second, let me check. Yeah, I just had a look. I mean, shoddy wiring on my part, but that red wire you can see there, that's the positive end of this 24 volt power supply going into this bank of terminals, and then there's a black wire going into that 0 volts. So that's fine. So let's we're not going into circuit breaker yet. We're going into terminals. So if you come down here and go to terminals, we are going into a bank of terminals. Now we have a choice here. So these blue ones are specific terminals. So this would be X0-1, whilst these blue ones are just like linked terminals, a group of terminals, X0 or X1, not the specific terminal in that group. So we are calling this bank here. It'd be better if I draw the layout first, so maybe I will do that first. But we'll call this X0 and this X1. So let's now we have two choices. Sorry, here on these group terminals, these blue ones, or if we go with these specific one, the grey ones. Terminal referencing terminal strip position, which I think is what I want to use, versus the terminal referencing the wire number. Now I have seen both in the real world, and I can't say what I prefer better. I just arbitrarily for now chose to use maybe I might have been advised it from someone who helps me out a lot. Yeah, I don't know. So terminal block number based upon the terminal number, I think is what I'm going to do. Yeah, so X0, that's what that's going to be, even though it started with X1 there. And then X1 we're going to call that. So let's make this one X0. Oh, it's not letting me change the name. I need to reassign it somehow. So I need to view my terminals. So if I click here on my project now, so this terminals, just like now I'm looking at my sheets, there's a whole new section of SkyCAD just called terminals, where you manage your terminals. So you click on show, and these are all the different sections of SkyCAD. So you've got sheets, components. So if I click there, it shows you the components I've got. Locations, I just got one panel right now. I could choose to do front, back, and top, like we discussed before. I've got PLCs, I've got laid out elements, systems, wires, cables. It will show the different ones here, and I'm going to click terminal strips. So I've got panel 1, X1. That's one terminal strip. I'm going to copy and paste this there. I can't paste it. Okay, so I need to do here, create. So I've got to click on my main project because I don't want to add a terminal strip to this terminal strip, which is X1. I want to add a new terminal strip. So here you can see under create add, when I've got this selected, I can add a new terminal, a new separator, a new end stop, a new ground terminal. Yeah. I want to click here, and then now I want to add not a new sheet. I now want to add a new terminal strip. There, I must first select the location. Okay. So the location is panel 1. We're calling it the whole panel. And then now I'm going to rename this to X0. this to X1. Hopefully that made sense. It took me a long time to figure out how SkyCAD's working with all of this. It takes some time to get used to. Just jump in and use it, and then as you start using it, come back and watch this video and it'll start to make sense to you. I promise. It's not complicated. It's just you know, there's a little bit of a breaking period. So now I've got to click this terminal that I've just done, and I've now got to assign it to this X0. So how do I do that? I come over here, not assigned to function, terminal strip tools, assign to a terminal strip. So now I'm going to assign it to X0, and then now they've both gone to X0. I don't know why they've both gone to X0. I wanted just a 1. So now if I do assign to terminal strip X1, okay, cool. So we now have a terminal X0 and a terminal X1, and obviously this is going to be for this entire bank X0 and X1. So let's do that. So now we can do power connection there, and we can go straight through it like that, and then here as well, and go straight through it like that. Cool. We're getting somewhere. I don't like this top bit at all. I don't like the fact that it's blue, so let's just, in my head, like neutral just isn't safe. So like maybe I could like arbitrarily color these brown, blue and green like that, and because I think I can do that, right? I think I can do like here blue. Would that work? No. There's a way to change this color. Yeah. I don't like that either, if I'm honest with you. Don't make it black. Anyways, it's not worth putting any mind into it. You get what I mean? Like, to be honest with you, my preference would be to just do this and just have it just blank, and my drawings start from there. Because ultimately, like, whether I do this or that, I haven't, like, the user hasn't gained anything from it. You just get that there's a 24-volt power supply here that takes 230 and you got to plug it in, sort of thing. So I'm actually just going to remove this. Yeah, and start from there. That makes me happier. Now, I don't know why SkyCAD does this, but it seems to like, I like my wiring to be like that, but it doesn't seem to like that. So, anyways. I'm not quite snapping to the, why am I not snapping to the same grid? So drawing, snap to subgrid. There. Cool. Alright, so anyways, a whole lot of fluff here, but we're getting somewhere. So X0 and X1. To kind of make a bit more sense, let's just quickly, I'll sketch this quickly now, and then we'll do it later on properly. But on the back face layout, or should we do, yeah, let's do back face layout. So we'll go on the back face layout sheet, and then we're just gonna this is gonna be a rough sketch that we'll improve later on. I just want to draw now this back face here. So let's start with our DIN rail. So we'll say that that's our DIN rail, yeah? Can I turn off this show grid? Okay, yeah. So let's make this line width 1 mil. Let's fill it and make it just all solid grey. Do that, cool. That's our DIN rail. Looks a bit like trunking, but let's say it's DIN rail. If we wanted to be like really clever, I just said I weren't gonna make it fancy, and I'm still doing it. Sorry, I just can't help myself sometimes. Fill like that, and then that starts to look a bit, do you know what I mean? That looks a bit better. So let's just put a few of these. Probably one more there or something. And then what we can do is select all of them, and then we should be able to align them all. Align objects, and then just line it with that. Cool. It's a shame that I don't think you can horizontally space them out properly. You don't like you can with like a Siemens, any HMI software, you'd be able to like just space them out horizontally. I don't think you can, from what I can see. No. So that's a bit annoying because you can see that they'll just look a bit. I'm messing about here, right? This is totally unnecessary, especially because I'm about to bloody cover the whole thing. Stupid idea. Let's just undo this idea. Stupid. I'm being silly. Alright, get rid of that. So, we've got a DIN rail at the back there. I'm now just going to draw the power brick. So that's just a black rectangle that goes straight over like that, let's say. And let's fill it. You can see why it was stupid. I was trying to draw the whole bloody... So that's our power brick. It kind of takes up a bit too much of the DIN rail. And then let's put some white text on it that says PSU1. Save that. And then we'll do what? Color. And let's do 64. Don't know. Can't see the thing there. Have I just done some text there? Alright, cool. Anyways, make that bold. Let's say, where's bold? Cool. So that's our PSU1 that we've drawn there, yeah? Not the best, not to scale at all. But, you know what I'm going for. Cool. So then we want to draw, let's just quickly, I'm just kind of doing this to make it more clear to you about the terminal things, yeah? So, rectangle. And then, so now we want a bank of terminals here, which are going to be our X0. This DIN rail is not long enough. I haven't drawn this to scale properly at all. X. Let's just fix this. This is not looking good so far. Let's fill it, and let's fill it with light grey. That'll be our bank of X0. This will be our bank of X1, which is, for some reason, I've done slightly smaller. Don't know why. Like, I'm actually using more 0 volts than I am 24 volts, I think. So, a bit weird decision to make. And then I've got my 5-volt regulator, which you can fit in black. And then I've got a bank of MCBs, which, let's just make the DIN rail stick out. So this is the sort of thing with layout drawings. I've kind of, I've just seen them done so differently all the time by everybody that it's kind of hard to say what is the correct thing to do. I think ultimately you're just doing it because you want the panel builder or your production team or whoever's building the thing to have an idea of what they're doing, basically, right? So it's kind of just like a visual aid. Like, ultimately what matters is the schematic, and that the schematic's correct. And then, yeah, obviously some people with their layouts, they do a whole bunch of dimensions and stuff, and so you can do that to make sure that they put it bang on precisely where you said. So again, you can do that. It's up to you. So let's just put 5-volt reg. Let's see. Maybe let's put that on a new line. If I hold Shift, Enter, and that goes onto a new line. So 5-volt regulator. And so this is X1. And this is X0. Cool. So that's a cheeky backface layout drawing that I've done, yeah? And then on the terminals one, I would now then delve deeper into how these X0 and X1 are laid out. Let's just quickly align all of these so that they look pretty. It may not actually align correctly. Yeah. That 5-volt regulator was never going to align properly. If I just press up a few times. There you go. Cool. So, I think let's just make this DIN rail stick out a bit more. Makes it look a little bit better, I think. Yeah, cool. Alright, so this is to say that this is 24 volts and this is 0 volts, which I could Like maybe on here I could actually just say that, yeah, look, it is 0 volts. It is 24 and 0 volts. Let me not do that now. So what was it in? Power distribution. So that's my X0, which is this whole bank of 24 volt terminals, and then this is X1, my whole bank of 0 volt terminals. Yeah. So next up now, I then go. I then branch off from here, I guess. So this is where the schematic now, you probably want to go just all the way down. So if I click on this connection that I've drawn, if I click on here, I can drag the whole line around, yeah? But now I want to extend this all the way down to the bottom of the page, because I'm going to branch off of it now into many different devices. So what you do is you hover over the end of it until you get this red circle, and then you can just pull it straight down like that. If I just show my grid, and then just pull that straight down there like that, and same for my 0 volts. Cool. So I now want to go to 1, 2, 3, 4, 5 MCBs. Let me just quickly check what MCBs I'm using. So I've just checked what MCBs I've got. So I've got a full 5SY6102-7 2 amp MCB, which is like the newer blue ones, and then I've got the older black ones which don't have the 102, the 02-7s, and it's still just a C2, so 2 amp, and then I've got a 1 amp one on the end. So what's interesting here, and just like the wiring here is so bad looking at it, and like, you know, now that I'll have drawing, I'm gonna redo this wiring properly. So like I've got the wires coming out the bottom here of these X0 terminals, and it's going into the bottom of the MCBs, which is just like, to me, you always go in feeds in the top, out the bottom. So I've just, quite a simple circuit really. I've just got wires coming out the X0 going into, should be the top of the MCBs, but the bottom of these. Do I have 5 MCBs there? I don't have 5 MCBs in real life. Okay, so yeah, this is quite an old video from 9 months ago, this one that I'm looking at here. So if I come over to this video instead, that's actually the circuit that I've got. So it's a good thing I'm actually looking at in real life, because here I didn't have I've removed my safety relay. So I've removed an MCB to make space for a safety relay. So I've got a safety relay here. So actually, drawing that up should be some fun actually, because safety relays are always quite intriguing. So all right, we need to draw these 4 MCBs, or put the schematics on for them. I guess I should actually just put the safety relay into that layout quickly. So let's do that. So that front face layout, where was it? Back face layout. Okay, sorry, freaked out a bit there. So these MCBs, let's make this a bit smaller, and then let's give us, copy that. So safety relays are kind of a bit bigger and thinner. Let's make it a nice yellow, and then we can put, what do we do? F relay maybe? I don't know. K1 probably is. I actually labeled my relay, output relay, K1. I guess this one should be K1. F-K1. I don't actually know how would you reference the safety relay. I think FK1. That might be able to do. Let's just quickly ask ChatGPT. So I asked Gemini and I asked ChatGPT, and ChatGPT came up with K1, K100, SR1. So I actually think SR1 is the standard. That's what I'm used to seeing actually. I'm not used to seeing FK1. Although quite interestingly, they both liked my FK1 idea. So I don't think I've seen that in real life. It's definitely SR1. It should be. Gemini, actually, sorry, ChatGPT says SR1. Gemini came up with K1, K2, SK1, SK2, FK1. Yeah. So Gemini kind of likes my idea as well. But I'm going to go with ChatGPT's one, which is SR1. I like that. That fits the bill nicely for me. Let's just... Oh, it's still playing. So SR1. That makes much better sense to me. That's what I'm used to seeing actually. Cool. So It is midnight, so my brain's not really operating at 100%. All right, so what was we doing? Power distribution. Let's get these circuit breakers in there. So if I double click this one now, I've got a Siemens circuit breaker, and the model number is the 5SY. So if I just go industry more, reject cookies always. So part number in there. Oops. Part number in there, and then what do we want? I don't really want to put voltage. Maybe I can put current, which is 2 amps. I believe. Yep, 2 amps. Voltage 230, 400 volts. Kind of. I don't want to put it because I don't want it. It can get confusing for somebody looking at it to think that I'm putting 400 volts in, which I'm not. It's rated obviously at 230 or 400, but I'm not. I'm just doing 24. So let's. I guess. Do I want to put the description in? That's what I just said about not doing. But I think I'll just copy and paste it and leave it at that. So that's that copied in. So if I go to my parts list now, we can now refresh, and we'll see there's our parts in. So power distribution, let's copy and paste this a few times. It's annoying that it's doing Q's. Why are you doing Q's? Copy the MCB2. I just click cancel. Alright, still took it. MCB3. MCB4. Cool. Not great that they're not far enough apart, but that's okay. Is that good enough? Cool. Alright, and then so these are slightly different in that they are the 5. Oh dear. They are the 5SY 61. I don't know. I don't really get what the difference is between the blue and the black. Don't know. RS. Oh, they're showing the blue ones. So what I'll do is just on my parts, I'll just remove that. I'll keep it as it is on the actual device, just so that it's actually different. So is it 6.1 on the actual device? Yeah, 6.1. And then this one here is the only difference one where this is 1 amp instead of 2 amps. So 1 amp. Cool. So again, on the parts list, look at that, automatically updated perfectly. So part numbers there, that's the blue one, and then you got the 2 that are cool. So that's our MCBs. If we now do drawing, connections, then now the way you draw this kind of is pretty difficult, because you might be tempted, for example, to do this. Because electrically, right, that's fine. But obviously, to someone panel wiring it, and maybe actually this is the way that I should wire it. Like, I'm currently running an individual wire from my X0 terminal individually, 1, 2, 3, and 4. So like, literally, you can see that one wire. Sorry. One wire going to there, one wire going to there, one wire going to there, one wire going to there. Now this suggests I've got one wire going to here, and then I jump, jump, jump. That's what that suggests. Maybe that's the right way to wire it, but obviously I would kind of because normally in a panel you just put, like, you know, you've got the jumper bars that just get inserted in, and it's just like, it's a bus bar basically. They slide in, and they're very efficient, very good way of just wiring up a whole bunch of MCBs. Just right along the top, jumper bar in, you're done, all of them connected. I don't have a jumper bar, so I could double crimp and jump over. I don't have any double crimps, I'd have to buy some. So I kind of just think I just will run 4 individual wires. It does give me then like some leeway if I ever wanted to remove one, but yeah, I mean. So running 4 individual wires then, how do I want to draw that? Because for example, if I was to go to now terminals, and let's say I was to grab my terminal again now, and I was to do this, like that suggests now that I've got a terminal and another terminal, and I don't, I just got one terminal. Yeah, so this is a tricky thing on how to draw. I think I'm gonna make a bad decision here, and if you have a better way of how you would do it, let me know. Ultimately, I don't think it totally matters. Obviously, I mean, in this instance, it definitely doesn't matter at all. Wait, what's going on here? I'm trying to delete. Okay, there you go. I was pressing delete and I went deleting. I think ultimately, for my project, obviously this doesn't matter. It's just my home PLC rig. It doesn't really matter how I draw it. And then for the customer, it's probably important, I think. So yeah, I think what I'm gonna do, and you can tell me if this is right or wrong. I'm just like, whilst I'm talking, I'm debating myself in my head. I'm thinking, what's the correct thing to do? What's the way to make it so that if someone's brand new to this, that they understand what I'm doing, and they can learn from this. And then how do I deal with all the people that are like totally not brand new to this, and I have no idea why they're watching this video, that are totally gonna rip me to pieces in the comments. And in my head, I have to kind of ignore the people that are gonna rip me to pieces in the comments, obviously because this video is not for you. So if you are gonna rip me to pieces in the comment, I get it. So I could, for example, now do this. Now again, that's a bit dodgy because the pass wire does not split. It goes into an X0 terminal. So yeah, I think I don't know what I'm gonna do. I should have planned this before I did the video. Crap. Okay. Ultimately, the intent of what I'm trying to do there is clear. I think if I have a better think about this, maybe when I'm driving to work tomorrow in the morning, in 6 hours time, I might change my mind, and then maybe in the next video I'll be like, okay, look, we're gonna do it this way instead. But for now, I'm gonna draw it like that. I'm not happy about that though. I don't quite like that. Yeah. It's almost like, I guess what I would do, looking at it now, I would put one terminal here, single terminal for my positive, single terminal for my negative. So that takes the power supply input into there, and then I would have then it come to X0, so that these would all be X0. I think that's good enough. I'm sorry if you're gonna grill me in the comments. I'm sorry, and if you have constructive advice as to how you would do that to make it clearer and easier, please give it. But regardless, I'm sorry. And yeah, I mean, if you're brand new to this makes sense, and if you do this, totally acceptable. Customers and employers and checkers are going to be totally fine with it. So cool. All right, let's move on. So I've got my 4 MCBs there. They're all labeled up, and we've got X0 terminals there. So let's now, we need to figure out where are these actually going to. So I'm just gonna, I can't remember what I did a year ago when I did this. I'm gonna guess that one is for the PLC, one's for the HMI. Oh, sorry, one's for the PLC, one's for the PC. For one, yeah, I don't know. One, yeah, I don't actually know. I'm gonna take a look. 1 second. Whoa, that was a bit scary. So I went to go have a look at my circuit, right? And then like, so basically this circuit breaker here powers, I forget now. Oh crap, I've forgotten. I think this one powers my network switch, which is a bit weird. 2 amp, I don't need a 2 amp on the network switch. This one powers my network switch. This one powers my PLC. This one powers my PC, and this one powers my Arduino Opta. And then I just spent like 10 minutes just totally panicking because the Opta wouldn't turn on. So I then thankfully went and found, looked through on the Arduino forum, and then someone actually said just double tap the reset button and it starts. So like the Optod wouldn't just turn it wouldn't turn on. It's a PLC and it wouldn't turn on. And I've now just had to like double tap the reset button to totally reset the Arduino. That's like that's a bit shit. Like that's crazy. Anyway, so I need to sorry, I just like totally got derailed there. So Arduino, PC, network switch or PLC, which one? Let me just quickly double confirm. I've forgotten. Cool. So yeah, Siemens PLC first. So 1200, network switch, Arduino PLC, and then no, sorry, PC, Arduino PLC. So you can see that. I mean, that's just like because I don't have drawings, and I've just kind of cocked this together up, you know, at midnight, a couple of midnights in a week or something. It doesn't really make sense. So we'll draw it as it is for now, and then we'll start to, as you draw stuff and you get it on CAD and paper, then you can start to like criticize yourself and like, well, that's a bit dumb. And looking at this now, like, this is a bit dumb. So let's just, for now, let me just quickly stick some text here just so I don't have to keep running back and checking. So what is it? It's Siemens PLC there. What's the next? What was the next one? Network switch. Which why is that on a 2 amp breaker? That makes no sense. I mean, it doesn't even need to be on a breaker. Like, yeah, it doesn't make sense. Why would I ever want to turn off my switch? Next up is the PC, and last is the Arduino PLC, which probably just had its program reset and probably all of its network parameters. So that's going to be a pain in the backside. Anyways, now we know what's what. I'm not going to keep these labels here because I'm going to actually draw the thing now. So there's a few interesting things about SkyCAD. One of them is that they do have quite a lot of models, mostly American Allen Bradley stuff. So if I open this PLC's thing, it's probably going to take a while because I think I've got a bunch of custom blocks that I've drawn. And I think for all 4 of these, I'm probably going to draw a custom block. Now there's a few ways to handle this. I can't exactly remember what's available in the free plan versus the advanced plan. So I think I'm just going to custom draw everything. But they do have, so for example, like here, they've got just a HMI template thing there. So like that is just a very generic 3-pin HMI. I don't even know what the 3rd pin would be for. Maybe ground, I guess. Positive, negative, ground. So that's just a generic. It doesn't have a part number. When you double click on it, it's totally blank, yeah? Then they've got like a 1762 L24BXB. I don't know what that is. If I drag it on, it looks like this. So you can see it's okay. So it's an Allen Bradley device, and it's an Allen Bradley, I guess, PLC. 24 volts, I guess 0 or COM 0. That's, I guess, not connected. Earth, and then inputs along the top, outputs along the bottom. Very standard sort of PLC setup, right? You can see like that's what the PLC looks like there. So if I delete that, then I've made, so I've got like the ET200 SP sort of model that I've made, which I don't use this anymore. I've also got a 1200 model, which I can pull there. So that's got like the full inputs and outputs. This is the Gen 1, so you can see G1 there. I've even got probably the G2. I've got a logo model, which is like a full DXF that I brought in. So I'm not not entirely sure what is. Okay. I thought I just because this is a DXF. It's like all of this tiny shape, so that took a long time to put in. Let's just delete that back out. So what I want is just a generic bog standard thing. So this is like the perfect thing. Where it's like, this is a Siemens 1200 with just generic terminals where it's just got the Ethernet ports, and then just positive and negatives. So for the power connections, so I'll delete that. Let's now. So I don't think I'm going to use any of these. Is what I was kind of trying to get at to you before I start waffling. So PLC couplers here. Okay, a 6ES7. What device is this? It wants me to assign it to a PLC. I don't have a PLC, so I can't do that. Okay. So let's. I think we're just going to draw the thing manually. There is a way which I might try and do, which I've done. I have done this before, but not for a long time because I now just copy and paste it. But there is a way to like create a PLC, or trying to think if I want to do this or not. I think for the sake of time and brevity and stuff, and this video length, I don't want to. Like, this is already 45 minutes. Let's just draw it manually. Keep it nice and simple. So my Siemens 1200 takes just a positive supply from this circuit breaker, and then the negative supply takes from this negative X1 rail, yeah? X1 bank of terminals. So let's do, I think we'll do a rectangle. Let's make it snap to grid, so not to our subgrid, but snap to our actual main grid. Quite important to snap to the main grid if you can. And then see, there is a way of like creating like nice terminals and stuff, which I'm not going to get into. Maybe the next video we'll do that. We'll create proper PLCs. I'll show you just briefly what I mean in case I don't end up doing it. If you go SkyCAD and then creating PLCs, using PLCs, then they have some nice tutorials on basically how to set up PLCs like that have configured IO. It is very good. I'm not going to do it here though. So if I now do circle radius, let's do, I guess, on here and then on here. This will be our terminals. I'm not totally thinking straight. 1 second, let me think about this. So the 1200 PLC is I've been hit by an advert. Who put adverts on my video? So the 1200 PLC takes 24 volts just into the top, and then it does also take 24 volts into the digital inputs, and then also again into the bottom on digital outputs. I'm just thinking about if I want to draw that here now or not. I think no. Again, there's a few different, if you don't know what I mean, if I just do this S7 1200 wiring diagram, I think that's what I'm gonna look for. This, yeah. So if you look here, the it takes 24 volts into this input here, and then it gives out 24 here, which I'm not using, and then it needs 0 volts into that 1M there, that terminal. So I'm debating now, do I simplify this drawing here, and then it also needs 24 in there and 0 volts in there. So I think I am going to simplify and draw this whole thing, which it's not going to look great, but okay. So let's just pull all this way out here for now to give us some room. These are all just a bit too thick considering like how thin these MCBs are. It kind of doesn't go. So let's do 0.3 mil. I'm sorry that this one's taking a long time. 0.3 mil, cool. And then we probably want to fill these in. That added a fill, make it white. Yep. Fill, make it white. Cool, great. All right. So these will be our bottom 24 volt. Oh crap. That will be our bottom 24 volt terminal, and then we'll do our 24 volt input, and then we're going to do the 0 volt input into there. Again, this is not a great way, but again, the point is just to get across like the power distribution side of things here. So we need 0 volts in there. And then it's just whether I need a 0 volt on this analog input. I'm not sure I'm actually using analog input, but I very well maybe and will do in future actually. So I'm going to guess that this 24 volt. Okay, there's nothing wired to my analog input there. Let me just check in real life what I'm at. Okay, so yeah, I am now actually wired in 0 volts into that as well. So I guess we have to extend this now, which is okay. To be there. Cool. So this, is not a great drawing. I think these circles are just too big as well. Oh dear. Can I make them smaller? I can. Bit finicky, but I'm getting there. This might look a bit stupid to you, but I promise there's a method to this madness. I should probably just have a quick look at my work drawings to see how I've done this, which I will do actually, just real quick. So on my work drawing, okay, well, so if you just have a look. So what I've done, okay, yeah. So I've drawn just a full PLC here, and I've just got it fully wired in like that. Same for the HMI. And then I've got digital outputs wired like that. So I like that. That's much clearer than what I'm currently trying to do. But yeah, okay, it's fine. So let's now, if we let's give this, okay, we can put that label there for now. We can amend that later. So if we hide the grid, come up here, we've got a 24-volt input there, and then to there. What was it? What did I do on my work? Does it have a dot? They don't have a dot. Okay, it's still just very large circles. Doesn't look good. I'm being a bit like too pedantic here, so like I want to make the circle smaller. They just look silly. Like obviously terminals don't stick out that much. Cool. All right. So back to grid. So that's our main 24-volt in there, and then how am I getting 24 volts to the rest of it? I'm currently just wired in without the circuit breaker, which seems interesting, right? Like that seems like you wouldn't do that. So what do we have? Let's go back to our wiring diagram. So it's 0 volts there, 0 volts there. So that's pretty straightforward. We can just literally do this. But should you do that, or should you do X1 terminal again? This is where it's like tricky to make a decision, really, because like now I'm not being consistent. I'm going straight to that one, whilst there I'm like literally specifying it X0. So it's almost like I should just do that for all of them, which I might do. What do you think? Let me know please in the comments, because I'm going to wrap up this video now. So do I do it like that, or do I do it with the terminals drawn? I don't know. So this is also again another 0 volts, but again this looks like a double crimp, and it's not a double crimp. So I'm kind of, it should be a double crimp actually. So I think I'll just buy some double crimps and then make this a double crimp, and then that's actually legit, because those all should just be a double crimp. So I think I will just double crimp all of them, and just that then solves the problem. All right, so this is also 0 volts to the analog input, and then now the digital outputs bit, that to there like that. Cool. That took far too long, but we are getting somewhere, right? So let's just make this 36 S7 1214C PLC. Stick it there. Cool. And then if we wanted to, we can add some labels to these to kind of make stuff make a bit more sense. Maybe like just move that up a bit. I think that kind of messes with things a bit. That should be like a bit closer. These should probably be a bit closer as well. Oh, I can't get it. There you go. Alright, that will have to do, I think. Let's just quickly. I keep saying quickly, and it's never quick. Just draw. I don't know. What is it? What does humans call it? Is it L plus? Yep. So L plus there. I need to go into the subgrid here to move. Yeah, properly. And then we'll do an M there. Then I think this next one's 2M, if I'm not mistaken. 2M, and then is it 3M? 1M, sorry. 1M, and then 2M. This obviously does depend on what model you have in terms of PLC. 2M. If you don't know why it's M, it's like just M for common, German thing, I think. And then 3L plus and 3M. So 3M and 3L plus. So I guess I don't here now, like, because my work schematic here that I did, that this circuit's pretty, like, this sheet's very simple. There's not much to it here. Whilst this one, because I've got a PLC and then I've also got a network switch, I've also got a PC, and I've also got an Arduino PLC. I kind of wanted like a more simpler. This is actually what I had in my head, and I think it looks pretty good. You can tell, you know, based on the length of this video, that I haven't put much planning into this, so I apologize for that. That is definitely my bad. So what I could do, and I think I will do, is actually I can make all of this now a block that I can reuse, which is just worth doing, I think. So if I now do create, I don't know if it's a graphical block or a graphical grouping. I think it's a graphical block. Then I define the insertion point. I cannot add a connection within a graphical block. I don't know what that means. So now, anyways, it's still, it all moves together. But I didn't actually, let's just undo that. So what I wanted, okay, that. I don't know why it didn't grab the text of these, which I'm not happy about. So it's got that now. It's got everything I want, I think, except that. And then create graphical block, define the insertion point. Need to specify, yep, okay. And then now I think I can do PLC on here. Yep, okay. And then what I want to do, which I don't think I can do, the generic PLC models. Like, I now want to save this block. How do I do that? Drawing, block generator. Create graphical grouping. Don't know if I do this. Create graphical grouping, do that. Okay, we're getting somewhere now. So S7 12 14C. I'm probably going to already have something for that, I think. Save, specify the library. Okay, we're getting somewhere. PLCs. Lovely. Okay, this is what I wanted. Then okay. Have you done it? It's a bit laggy, but it does. SkyCAD in general is a little bit laggy, but okay, look, there we go, perfect. So now in my PLCs category, now I can do this. Boom, perfect. And then now it's actually pulled through as an actual PLC device, which is brilliant. That's what I wanted to do. So that's very good. So now I've got this PLC like drawing reference. So if I now come to my parts list, I now have a PLC there, which is brilliant. So on power distribution, PLC, and then now I can put PLC details. Brilliant. Very, very good. Siemens. And then we want to get the S71214C part number. Let's go with that. Do we trust RS? Probably not. Let's go with Palmley Graham. Trust it a bit more. There. I mean, RS is accurate. Actually, I'm berating him too much. I love RS. And then let's just get part description, which is this one. Description, delete. Yep, perfect. And then now in our parts list, give us a refresh. Lovely, look at that. Beautiful. I mean, that's nice. That came together nice at the end there. I was beating myself up a little bit, but that's worked out nice. So network switch wise, I think I'm just gonna do a very basic little square. Let's just try and wrap this up with just these 4. It should be pretty quick. It should be. You know, if it's not, I really apologize. It should be quick. So we just want a square the same size, like that, and then let's just do these. We want those 2 little circles if we can grab them. Don't think we can. If I can kind of draw a circle over it, drawing circle radius. I don't think I can get it because it's not part of the main grid. There we go. Give me that circle, perfect. So I think let's just fill it in white. Perfect, thank you. My network switch actually has 4 ports, but let's just not worry about it. I'm just going to just do the 2, and then, you know, anyone who's wiring it up should be able to figure out what ports are which, right? And I'm just going to put some text. Let's just say plus minus. Plus and minus there. Cool. All right, so let's move this MCB. Let's maybe put it here. Move that there. So I guess like we want all of these things to be actual objects, so we should probably always do that graphical grouping thing. Let's just make this text center aligned, and then let's add a new line, shift enter in there, and then now we've got network switch, lovely there. Go back up to our connections. I've lagged a little bit. Every time you open or close a group, it lags a bit. It like you can tell how they've programmed it. Like it's gone off to go and fetch the folder every time, which is a bit annoying. So now we draw our. I haven't actually lined my circles up to the grid. You can see, which is no good. Let's do that. That there, maybe. A bit more that way. Don't know. Not the best, not the best. All right, so and then negative, we'll just do. So we're not gonna join onto there because I think that's wrong. Just go this way here. Cool. So that's the network switch kind of done. As for the network switch I'm using, it's like an Aliexpress one. I think it might be an Amazon one actually. 2 seconds. So this is the switch I'm using. It's a Rouhani, whatever. It's just a cheap one off Amazon. So let's see. I should now. I think what I want to do is select all of this, and then let's do now create graphical grouping, insertion point, and then network switch. Save. Specify which library we want to put it in. I don't know if there's a library. There is networking, which is lovely. Click OK. Now we've got a networking block in there. Lovely. And then so, why is that not giving me a drawing reference? Let's see if I do this. Still not done it. Okay. Is that... Oh. Is that because it wasn't... I did that slightly differently than I did the last time, right? So let's just do that again. If you do create graphical block first, so we make it into a block, define its insertion point. Yep. And then, okay, yeah, there. This is how it gets its drawing reference number. So does it do any networking? Yep, we do. So now that's got NS1. Great. I'm happy with that. Then we now do create graphical grouping. Yep, define the insertion point, and then network switch, we can save over it. Yep, replace it, and that's it. So can I now, let's just check, delete, bring this one on. Lovely. NS1. Cool. So now we've got another part number, NS1 on there. So if we go power distribution, and then we can now add, just copy and paste that in, Ruani. So manufacturer Ruani, whoever that is, just some random Aliexpress thing. That we're going to get a part number for this thing. Let's just give it a quick Google. Yorkshire Outdoor Activity Park is selling network switches. Make that make sense. What on earth? What on earth? I don't even know what I'm looking at here. There's a skew here. Probably total nonsense. Why is Yorkshire Outdoor Activity Park selling network switches? Yeah, I don't think I'm going to get an actual serious part number here. There's probably not even a data sheet for it, let's be honest. You can see I bought it off Amazon, but it is just an Aliexpress thing, isn't it? Any part number? Nope, nope, nope. Anyways, doesn't matter. Just you get the deal for now, right? How to do this. So that's the network switch done. PC. Yeah, this is an hour video, so I think I'll stop here. You kind of get the point what we're doing here. We'll add the PC, we'll add the Arduino PLC. Maybe I'll do that off camera. It's pretty simple. Just kind of rinse and repeat of that, right? Put a square on, add some circles for the ports, for the connections. Then turn the square into a graphical block, and then into a graphical group. Save it in your library, and then you can drag and use it on, and then it will produce NS2 every time, etc. Cool. All right, thanks for watching, guys. So next one, we should hopefully start to do our PLC inputs. You can see that, like, for me, this becomes quite a long process, just because I have to get all of my thoughts out onto paper, and that's probably the hard part. The easy part is actually doing the drawings itself, which is funny, right? Like, because you could kind of see how, like, I've heard people discuss before, like, well, you're just drawing lines, like, why is it difficult? And the difficult part is understanding what's in your brain and how you're going to get that, put that on paper, and how other people are going to understand that. And that's the difficulty. So yeah, cool. So in this video, we started our, pretty much almost finished our power distribution rail, and then we've done our little front or back face little drawing here, and then our parts list is coming along nice. So we are definitely going to have to copy and then make another parts list page, and then we're going to have to basically split. So you click this parts list block, and we're going to have to come over here and, how do we do it? Split list block, and we're going to have to split it in half because it's getting quite, it's going to go over this, what this one sheet can contain. So you can see there, why is it split? Interesting. Something's gone wrong there. Okay, there, cool. So you got MCB1 and then NS1. So if we, what do? We want this one on sheet 1. All right. So sheet 2, delete this, take this, so copy that on there. PLC, what's going on? I don't really know what's happening there. That's not quite right. Let's just check. So we've got the 4 MCB ones and then NS1. Okay, cool. Yeah. So now that split the block across 2, and then as you start to add and create more parts, these will update. So yeah, we need it kind of in 2 pages. Cool. All right. I will promise. That's it. We'll wrap up there. I think the only last thing to do is just now up-rev our drawing so that we can come back to this point if we need to. So we do a file, save as, and then -C, and then we will just as well do it here on our number, because we want to change that bit there as well. So look, we've got HA001-B, and then do that, save all, and then now we've got a -C. Cool. So we've up-revved, although, yeah, cool. Alright, yeah, that's it for me. Thanks for watching, guys. Sorry this is so long. Next video, not sure what we're doing. I'll do these, and then, yeah, next video we'll start with some PLC inputs, which should be some fun. Cool. Thanks for watching. Take care. Bye-bye.